I'm your host, Grayson Berolti. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends in mobility with leaders and innovators to make it all happen. On today's episode, we're absolutely honored to welcome Joerg Grotendorst, Senior Vice President, Corporate R&D, Magna International. On today's episode, we'll discuss Magna's approach to the future of mobility. We hope you enjoy this episode. Joerg, welcome to the podcast.
Well, thanks for having me. Happy to join the show today.
It's great to have you here. Magna does more things than you could probably count in my head for vehicles. You make parts, you do strategy, you make components, you do all sorts of wonderful things, which puts Magna at the core of the car.
Yeah.
Obviously, you have to think about the future of the car because all the parts and different business lines that you have in the vehicle. In your opinion, Joerg, what is the future of the car?
Oh, wow. That's a great question. There is not the one future of the car, you know? I mean, we talk about different kind of applications. We talk about different continents, different countries, and different kind of customers. But that's what makes this job so interesting. We talk about individual mobility, you know? Public mobility is already installed. We have trains, we have all the other devices to go. We have buses, but individual mobility means that customer can choose different kind of cars, different kind of vehicle, different kind of transportation. And that's what it is about.
Do you see it from different continents, countries, cultures, perhaps the design of the vehicle changing or the interior of the vehicle changing just because of local customs?
Yeah, definitively. I mean, we have different kind of interests we see right now, especially in Asia, front running in terms of in-vehicle infotainment and vehicle connectivity, smoothless integration of mobile devices, individual lighting systems, etc. Whereas I would say the Western country, Europe, is still a little bit more on sporty cars. We have in Germany still no speed limit on the Autobahn. Yeah, and when we change over to the Americas and look as well to the Australias, the cars definitively are much larger, bigger. There are more kind of transportation. We have much more trucks, not really a problem of parking and stopping the vehicles as we see, for example, in Japan. So yes, we see a wide variety of future cars and not a single one. It would simply be boring if there is one car of the future that everybody would work to.
We don't want boring. Plain and simple. Consumers don't want boring. If you look at the Asian markets, historically, Japan has been a very incredible engineering culture around electronics. And if you look at the APAC region, if you look at China today, and you look at the Beijing Auto Show, there was a common denominator at the Beijing Auto Show. Everything was built around infotainment and the in-car experience, from the Xiaomi car to the XPeng car. It was all about the experience. Do you see that infotainment experience that we're seeing at the Beijing Auto Show and various Chinese auto manufacturers start to come west at some point? That experience starts to come west?
If you look on the current markets of global vehicle players and manufacturers, there's a huge difference in especially what you mentioned in Beijing and what we see in APAC Asia right now. At the moment, the Chinese automakers are especially focused on the Chinese market. That's where we have a really high acceptance of in-vehicle infotainment system, where we even have the infrastructure and where vehicles can be updated pretty fast. Yeah, all the established players, they have a total different approach of vehicle designing. They try to design platforms where they then have derivatives of in the different kind of countries and areas all around the globe. This is, of course, much more complex, because if you have a vehicle design that shall fit for the Western world, the Eastern world, different kind of body set you have on top, may this be a limousine, may this be a wagon, or even a spider application. So that's totally different kind of vehicle design approach. And this is why we see right now in China a much higher speed than we see in the rest of the world, because at the moment they're dedicated to the Chinese market. But yes, once they have the experience and technology that they can provide, we do expect that Chinese OEMs will come over into the Western world. We see it right now. The first OEMs are talking about building vehicle factories in Hungary, for example, Mexico, or whatever. And then they are approaching the Western world as well. But that's the history and the way of learning they have to do, which on the other side, the global players already have.
The common denominator that's going to connect all this is going to be software. The software of the vehicles with the over-the-air updates is going to change from an infotainment standpoint, from a performance standpoint, from an autonomous standpoint, which raises a question. When does the phone become the key? So you go in your vehicle, and I perhaps go in a similar vehicle. You might like a blue interior. I might like a white color interior with the lights. I might like to listen to classical music on Spotify. You might want to listen to rock music. When does the phone become the fob? So when you get in that vehicle, it's the Joerg mobile, and when I get into the vehicle, it's the Grayson mobile. When are we going to get there?
Well, we are already almost there. I mean, first vehicle approaching and unlocking or locking with a mobile device, that's standard meanwhile. And yeah, good question you're asking. If you talk about illumination, different kind of interior and even exterior. Yeah. If you have an idea or if you have a wish come to Magna, that's something that we do offer in our Lightning division. Yeah, we are working on this. And to be honest, it's not a design that is directly given to the car as a styling design. No, what we try to do now is a more luxury approach. Yeah. That, for example, you have hidden lamps that we provide materials that fully cover the illumination, so you don't see it. May this be on the outside, you don't see a blinker anymore, you don't see internal lightnings, LEDs, neither bulbs or whatever. And yes, when you approach the car, suddenly you wonder that we have a shine-through technology that then illuminates the car in your personal style and the way you like it best. Yeah, and that's something which I think is really a nice styling feature. And yes, me personally, I do like it. And yes, I trim the vehicle to the style that I like. And sometimes I change it even while driving, depending on my mood or my attitude or the length of the journey or whatever. Yeah, but that's something we definitively work on.
Now I'm going to give you the Walt Disney phrase, plus it. And so, because Magna you do really great engineering, so we're gonna plus it. When does augmented reality and AR enter the picture, where the glass becomes augmented and you start to enhance that experience?
That's currently under development. Yeah, not so easy in a car. Yeah, as always, you have to consider different lighting conditions, weather conditions, driving scenarios. Under development right now. Will this be a huge step forward? No, I think augmented reality in the windscreen, or at least 3D simulation, we will see in the next 3-4 years on a broader market application. But will this be something that we have in all the cars? No, definitively not, because due to different classes of vehicles, pricing classes, application, it doesn't make sense for everybody. It always depends on the purpose of use. Yeah.
Do you feel that the hardware or from a strategy, the hardware will be shipped and then your customers, the OEMs, could then activate it for a subscription fee depending on the different types of vehicles? So Magna's shipping the hardware there, and then your customer has the ability to activate it if they want, so you don't have to go through this whole redevelopment, redesign cycle?
This is a real good question, because currently you're very intensively discussing what is the end customer willing to pay for the application. And from a technical standpoint, of course, it would be the easiest to equip the vehicle, let's say, with all majorities that customers may take, and then the customer can pay per use or pay or load software up, download software afterwards when the car is not even anymore brand new. But therefore, the hardware has to be in the car. And I think that's something which is typical for the automotive industry. It is very, very price sensitive. So I assume that not for features, for example, electric seating, if you want to download software for electric seating and activate it afterwards, you have to imagine the ECU and the motors have already to be installed in the vehicle right at the beginning. And what if the customer doesn't want the function? Then it may not be a positive business case for the OEMs. So if we talk about all the devices that are mandatory in a vehicle, a large and super performing control unit and displays and everything, that definitively can be added with future functions afterwards, definitively. But if we talk any kind of performance of the vehicle, braking performance, seatings, electric windows, roofs, or whatever, where you have to install real physics hardware. I think this will not be something that can be downloaded to add another function afterwards when we talk about mass production. The risk of underutilizing and having much more hardware where inside the car that drives the price and the cost up for the OEMs and the end customer, I assume is too high.
It's a double-edged sword. We had the GM earnings yesterday, and I read all the Wall Street analyst reports, and Wall Street kept saying, okay, GM, turn on the spigot for services for the in-vehicle activations, but you're right. If GM's going to do that, they're going to have to contract with Magna to put the parts in there to turn it on. They're going to have to run the business equation. And so it's that chicken and the egg. Which one are you going to do? Because as you know, very well, and our listeners know, the margins in automotive are very small. Sometimes it's pennies on the dollar for certain components, and you start mass manufacturing it. The vehicles, and you and I both know, they're changing. Sensors are becoming more ubiquitous in the vehicles. As the vehicles start adding on SAE level 2, 3, 4 levels of autonomy, how do you see the sensor suite change? Because right now, the majority of the individuals believe that it's for level 4, it's LiDAR, camera, and various sensors, that's part of the stack. But how do you see that changing? Because to me, when I run the numbers, not every individual can afford a $400,000 car with a souped-up sensor suite to achieve the level 4. How is that going to change?
I absolutely agree with you. We believe that it will take us a while to offer level 4 autonomous driving. For the next decade, we assume that level 2 and level 2++ will make it. Even the jump or the next step to level 3 is already a burden for the industry, because the major difference in between level 2++ and level 3 is that you have to add more computing power. We call it SoC, yeah? And so you have to have a redundant SoC compared to level 2++. That's some hundreds of dollars you have to add to the vehicles. And I think, and here I agree with you, not everybody can afford it, and not everybody wants to afford it, because it's not a business case for everybody. If you go on a daily route into the office, or sometimes on a long range ride, it absolutely makes sense to have autonomous support for highway driving, autobahn driving, or whatever. But is it really a business case if I go downtown for 20 minutes and my vehicle then guides me fully autonomously throughout the city, forward and backward? I think that will take us a while. At the moment, in terms of costs, we are at a too high level. Doesn't mean that this will always remain, but we are at a too high level. And I assume for the mass of mobility, it's not a business case right now.
It's always going to come down to cost. There's no way to slice it. It's going to come down to cost. And
yeah,
there's no way to slice it. If you look at cost, LiDAR is very expensive. There's public data on that. Well, and then there's a big debate. Well, will 4D radar? Will there be an imaging breakthrough with cameras? Will depth sensing technology? Will the CMOS technology? Will there be a big breakthrough there? In your opinion, will LiDAR always play a part of the stack, or could there be some technology out there that's emerging that has its ChatGPT moment, and the world says, oh, wow. But the big difference is this technology will not hallucinate like the ChatGPT does.
Yeah. So we are working, of course, on different scenarios. How far can it go? We can match different kind and classes of perceptions of different kind of sensors. So imagine we are one of the largest supplier for thermal sensors and cameras on the world. Yeah. Imagine we can just patch in real time camera images with thermal, so video camera images with thermal camera images. There are some companies outside there in the world that work on different frequencies of radar that are not at the same performance as LiDAR right now, but almost. So you can imagine, once we have the tool suite and the software ready to put it all together simultaneously, same timestamp using, then we may have the same information that brings us close to level 4, and maybe we don't need LiDAR for that. I cannot grant it right now. We are not there at the moment, but of course we are intensively working on that, making use of the sensors that are currently available and how to improve the performance to get in a more far out range to detect obstacles and see if this could get to a imaging LiDAR performance.
You hit the nail on the head. The L4 stack is going to change over time. You and I don't know which way it's going to change. Your scientists and the engineers out there will figure something out how to change it. Today, what do you feel is the best L2 stack? Is there an ideal stack that Magna sells to your customers that end up with the end customers that you feel from an engineering perspective product quality performance perspective, that is the ideal L2 stack today?
Yes, of course. We have discussions with most kinds of all OEMs all around the globe, and of course we have maybe the largest toolbox of any suppliers in the world. As said, we offer cameras, radars, ultrasonic, thermal sensors. So we have the full tool suite, and we definitively talk to customers that want more than 10 cameras around the vehicle. Then they try to combine what is their best solution. As you said, some of the OEMs bring in their own driving maneuvers or autopilot functions, so they better rely, for example, for value parking or better on cameras and on ultrasonic sensors. And we have to adapt to, but as said, we have the full range of sensor, maybe the most widest in the world. And of course, we have the ECUs with the high performance control units additionally. So we think we are well prepared. But if you again ask, is there one sensor set that all OEMs go for? No. Yeah, that's individual due to maybe even the performance the OEM wants to get, maybe even brand related, that they say we do it with cameras instead of other sensors or whatever.
That's fascinating. The OEM come to you and say, for example, let's call it Acme OEM comes to Magna and says, we'd like to work with you to develop an L2 system. Perhaps they take parts and software from Magna and software from their side, and you work together to build that ideal product that OEM's looking for?
Yes, definitively. Yeah, and that brings us to another topic, of course. What is the electronics and software architecture of the future? Yeah, you as an expert know as well as I that we are coming from a distributed organization in a distributed architecture in a vehicle, talking sometimes about more than 100 ECUs. Now, intermediate, we talk about domain controllers and high performance computers plus domain controllers, but we believe the future will be for high performance and luxury vehicles, at least the zonal architecture where we have high performance bus systems in between the ECUs. And then if it comes to software architecture of the future, we may even think about containerization of software. So for fail-safe reason, as in a plane, if a function or if an ECU has a malfunction, that we can shift tasks and jobs from one ECU to the other. That, of course, would be the best architecture in terms of safety and redundancy, and the most easiest one to maintain once it comes to software updates and OTA applications.
Then there's the issue of power, especially as you go towards electric vehicles. How do you engineer for power efficiency?
Whoa, that's a great question. And here I think we can play the power of Magna, how we call it. Yeah. If we talk about efficiency as Magna is such a wide theme. I mean, we started body design, using different kind of metal welding, screwing technologies, bringing together different kind of metals, and always we look for lightweight. We have great applications starting even with battery trays, how to create lightweight for battery trays. Then, of course, the heart is powertrain with the e-drivetrain that we design and produce in-house. And we do full drivetrain and even brake applications. We have designed in Magna a software suite that we call Magna Operating System. That's a software that controls driving behavior for steering, for the powertrain, for braking, and for battery control and thermal behavior in a car. So it's a mastermind. Yeah. And if we have OEMs that may be new to a Western or whatever kind of market and ask us for an application, yes, we can almost deliver a turnkey solution and tell them this is an electric vehicle, this is how we would design it. And this is, in fact, a specification that we are approached with from different kind of customers that say, we have a limousine, we want a drag factor of this kind, we want power consumption of this kind, we want a range of this kind. And then, it all comes together with all the product groups that we have, our body in white, our electronics division, our powertrain division. Then we have a mechatronics, mirrors and lighting, and then we get it all together.
You also have a design division. Obviously, wind plays, so drag from the wind. There's all these little elements, materials, fabrics, the treads on the tires. How is Magna taking all the, let's call it the collective resources of Magna? How are you putting those together to optimize for the range of electric vehicles?
Well, that's really something we have a know-how in-house where we have, let's say, design engineers that really can supervise full vehicle design, which we then do on a contractual base, of course, for OEMs. So we can do full vehicle design. We can even do full vehicle manufacturing. And then we break down the overall specification into product group specification. This is another domain right now where we heavily use artificial intelligence tools because it's not so easy. If we talk about the drag factor, there's always a compromise in designing the mirrors, the front grille, and the windshield, for example. Total different divisions. So how do we bring them together and not allowing one group to say we want the bigger but nicer mirror, then this impact on the drag factor is negative. So the boys from the front grille, they have to further optimize the tool. And that's, nowadays an iterative process where we more and more get to automatization as well to bring all these requirements and the different products into a balance. And with that, of course, fulfill the customer requirements as good as we can.
It's the little tiny details that Magna's very good at figuring out that you can extend your range even by a mile, 2 miles. That's going to help with range anxiety. We have charging anxiety. We'll get in a minute, but range anxiety. Has Magna done research or spoken with your customers, the OEMs, to determine what is the ideal range that they're eventually going to want to deliver to their customers?
There's not the ideal range. Again, this is, of course, something that is relevant in terms of pricing because the majority of all costs and prices for range is still the battery, which is the most expensive device in the car. But we have taken a car, yes, out of existing series production, a car that we know pretty well because we're building it from a customer, and then we rebuild it. So current mileage on the road is roughly about 400, and in the same vehicle, using our software and using a different kind of cell chemistry, we could increase the range by roughly 80 miles or something like that. So really significant, But of course, as said, a major impact will always be the battery and sizing the battery to what the customer is willing to pay and what mileage he needs. That's, of course, very relevant for the vehicle performance. And we see right now even customers changing the range or even select vehicles where you can change the batteries on battery swapping stations. So total different kinds, short range, mid range, long range, and battery swapping. We will definitively see all these solutions in the future markets as well.
How much more aggressive can regenerative braking get to help increase the battery? Could there be a software breakthrough? Could it be more intense? Because I have an electric vehicle and knows that the regenerative braking over the last year is pretty much kaput, and then turns out the brakes went kaput. So I had to go get the brakes fixed. But can you make the regenerative braking stronger to increase battery life?
That's something where people have to be educated when they buy their car. Unfortunately, I have to dig a little bit more into the technology, but I think I have a good example. Accelerating and decelerating the vehicle. Imagine you have two glasses of water. Two water glasses, sorry. One is full with water, the other one is empty. So now you accelerate the vehicle, you change completely from chemical energy in the battery to moving energy, rolling energy. So you completely give it into one, but you have losses. You always lose water. And when you brake and regenerate, you bring it back into the original glass, but again, you lose energy. And most batteries these days are optimized, and the inverters are optimized for energy to be taken out for acceleration, not for deceleration. So you lose more water when you try to bring it back into the battery than you have it for. And the more powerful the regen braking is, the more you get into accelerating and decelerating. And imagine you always shake water. So the best is to have a smooth software. And therefore, I'm personally not a friend of this one pedal drive. When you push the gas pedal that you accelerate and you release it, you directly brake, because then you exactly do with the water what I just explained. It's better to fill the water more slowly in. And if you really want to go high speed and you see an obstacle in front of you, brake right in time that you make sure you have a smooth water flow back into your original glass, because if you press too much, you always got in losses. And then, of course, there may be customer dissatisfaction that the range is not as good as prospected.
It's fascinating you say that. There's some individuals I know, older individuals, that went and drove a Tesla, and I can't say the 4-letter words here. We'll leave that. It's a children programming here. But the one pedal driving, this person was in their 80s, and there was more 4-letter words than you could imagine. I said, you can turn it off. That's not the point. Insert more 4-letter words. There was this. It's interesting when you get an older individual, let's say north of 70, that's used to having a brake and an accelerator. Do you feel that that's a deterrent because they don't know that you could turn it off, even though the vehicles that you manufacture, you can turn it off, and they just try this thing on a test drive and insert your favorite 4-letter words here.
Maybe the right solution is even to give the customer a chance to trim it. Yeah. The first vehicle which I know on the market, it had still a potty in the middle, that you really had a small wheel where you could trim your regen braking and find your individual optimum. Of course, if people really like the one pedal drive and they love it, yeah, it's a feature that of course you should allow the customer. But the danger is you have to be very, very sensitive with your food, and the impact on the range may be significantly without that the driver really realizes what's happening with the water even being exchanged in between the two glasses.
To achieve the all-electric future, we need infrastructure, but I'm going to caveat that with infrastructure that works and that's reliable. What can be done to ensure that the charging infrastructure is always operable, it's working? I can't tell you how many stories you go, broken.
Yeah.
Or it gets you have the plug-in and then the software has an issue. What can be done to fix that?
Well, we need definitively a smart infrastructure for that. Yeah, so all the charging pillars, they have to be online and by the energy provider continuously monitored via software and immediately fixed. As I'm an e-mobility driver as well, that's something I really hate most. Yeah, if you navigate from place A to B and then you do your optimized routing and then you get to either to a charging spot or even to a fast charging spot, and then it's defect and cannot be used. Yeah, we now get to a wider scope maybe, but to really provide green and sustainable energy to the mankind, we simply have to use the sun. That's the most easiest way, wind, etc. But to have the different kinds of spots around the world, they have to be all interconnected. And imagine the world as the sun is shining down with almost 1 kilowatt per square meter. And me personally, I even wondered when I saw a video recently from an athletics tournament in Rome, when the drone was flying over the city, that not many roofs were equipped with solar panels. Yeah, I mean, for me, definitively to equip roofs with solar panels, especially in areas where you have high temperatures in summertime and you need energy to cool buildings down. I mean, it's so easy, to create and produce the energy on site directly and use it for whatever purpose. And this is the same for the infrastructure. We need strong energy and power lines for fast charging at the highways, at the Autobahn. But of course, this has to be green. Otherwise, it would not be beneficial for the global and for the global CO2 emission. Yeah.
Is the connection that makes this all work for the smart infrastructure sensors, where it knows if something's broken or offline, or it needs to pull energy from, say, a battery backup or send energy somewhere? Does sensors become that glue that enables this?
I think so. It's not the sensor. Most sensors are in the systems by themselves, but the interconnection in between, that somebody remotely can diagnose what's going on, and in an ideal world send out a service technician that has the right device in hand to be replaced immediately, or do a software reboot remotely or whatever. Everything that we know from a mobile phone right now, that's not rocket science anymore. It's just a question of implementation, and unfortunately sometimes a question of of business case. Yeah, who earns the money at the end? How do we do energy and cost roaming? Yeah, that's an issue. Yeah.
Roaming, I haven't heard that since the 90s, early 2000s, where if you were in Germany and then you went
Yeah.
to Switzerland and then you went to Spain, oh boy.
Exactly. And everywhere you need different providers and a different app, and yeah, and that's really an issue. Yeah.
And then you had to swap SIM cards. I remember that was miserable because that was the only way you could actually work if your phone to work without paying an arm and a leg.
Oh wow, that would be new. I've never heard about that, but to be honest, I wouldn't be surprised in Europe. Yeah, I wouldn't be surprised. Yeah.
It was interesting. It happened. And you mentioned battery swapping. And so I've been doing research on batteries and studying batteries, and there's a common denominator that keeps coming up across all the research I've done is the weight of batteries. And then I started going down a rabbit hole. Well, the weight of batteries is increasing the turnover and brakes. It's increasing the tire treads. In northern Washington State, we have the SAM issue from all the tire pollution. What can be done to make batteries lighter and more resilient?
Well, I think the speed of new designs in battery and new chemistry is still pretty high. Yeah. And you may have heard about that Geely recently announced they have developed the first solid state lifetime battery. Yeah, that was one of a news that came out during the last, I think, 4 weeks or whatever. But in general, we can say that battery technology is moving pretty fast. And I think we will have a lifetime battery pretty soon. It will not take another decade to be right there. Then question is, of course, do we change electrolyte to become even more efficient and lighter? But here we have an ongoing technology. Major topic is, of course, then how can we bring the cost down and will it be affordable for the customers? From a practical experience, I think right now battery performance is today already pretty good that we have. There may be an anxiety with the customers to buy an electric car because the next generation of batteries may be even better. Same as with a mobile phone. When is the best time to buy a mobile phone? When is the best time to buy a computer? Because the next generation will always be more performant and may have new features inside. But on the other hand, this is, of course, the way of moving forward, bringing new technology and bringing new chemistry in the cars. For me, at the end, no question, the future is electric. Full stop.
The future is going to be electric. What can be done to bring down the cost of batteries? Is it a chemical breakthrough? Is it an engineering breakthrough? What can be, or is it just mass manufacturing that brings down that cost?
There are some topics that we have to consider. Of course, it is new design of chemical solutions. It will be larger production, of course, all around the globe. But it will be recycling once we have an infrastructure to reuse material and get recycled material back into production. And this all will help and will all bring together. That's not the one solution that will make the batteries cheaper. It all has to come together. And if batteries are fully integrated in a vehicle, when we get to so-called cell-to-chassis solutions, so we take out material for battery covers and battery housings, and we bring it directly into the vehicle to be a mechanical element that grants stiffness of the chassis and the body. That, of course, will take out furthermore weight and costs, and with that, reduce the price overall. But once we go that route, that, of course, prohibits in battery swapping, because then you would directly interfere with the vehicle chassis. So that's a totally different road in between fully integrated batteries and batteries that may be swapped.
Did you see battery swapping being done at a dealership level, where or a special battery swap, or where do you, if that becomes the future, how do you see that actually being done?
Well, we have some OEMs in the world that offer right now, especially in China, that offer already battery swapping. We have first stations in Europe. But you may remember, I'm now more than 2 decades in the industry, and maybe you remember there was a company at the beginning of the 2000s that was called Better Place. Better Place tried to set up battery swapping stations across all the OEMs, and they failed. to give some arguments why a company failed at the end is pretty easy. Yeah? Making it successful is rather more complicated. But it failed because you cannot harmonize battery design across all the OEMs. They have different packages in their chassis. At the time, we were even discussing about cutting the battery in two pieces. One piece really as a energy storage, one that could be harmonized for long range, and the other one could have been a different chemistry for the power and performance, so that you use different kind of cells and different kind of chemistries to provide power, that you get high current out pretty easy and fast, and then for long range rides where you don't need that high demand of power, just to drive smoothly, then to have an energy block inside of the vehicle that may be swapped. But it all failed because you have so many varieties in terms of performance and range that the OEMs have to offer to their customers, that it was not possible to design a standard and then design a standard for swapping stations as well.
The consistency of what you described, what was talked about today, change is happening in mobility. We are going into a new feature. Same from when we went to the horse and buggy to the gas powered car. We are going from the gas powered car to the electric car to the autonomous car. There is change on the horizon. Joerg, in your opinion, holistically, what does the future mobility look like?
The future mobility will still be individually, and I assume most of the car drivers, they definitively enjoy driving and riding a car. That's what is, so to say, against full autonomous riding. There will be definitively application and fields of application for autonomous driving, especially if you use a car for business. But there are a lot of people that enjoy driving and riding a car, and they only may want to give up the control of the vehicle when they go for long distance and want to relax while driving, or you have a family and you want to see a video or whatever. But my experience right now is, for the future, we will definitively have people that love to ride a car and enjoy it and buy a vehicle just to ride it and to drive it. So in the future, there will not only be autonomous vehicles and autonomous devices. We don't even know if future mobility, if we talk about mobility, will need wheels. There will be different kind of applications for mobility. People that love to fly, people that love to ride a car, but it still will be possible to do it individually. And this definitively will always be the cheaper solution compared to complete autonomous riding, flying, or driving.
The bottom line is consumers are going to have choice in the future mobility. They can fly, they can ride, or they can drive. They are going to have a choice.
Yeah.
Joerg, this has been a fascinating conversation. As we look to wrap up for today, what would you like our listeners to take away with them?
I'm convinced about that the car of the future, whatever purpose it is for, has to be sustainable. We all have to think about climate protection. Resources of the oil will be limited, but we all have to think about that in history, the Stone Age didn't end because we ran out of stones, and the oil age will not end because we run out of oil. But the better solution is always the enemy of the good. And that's, I think, what we talk about, or what we have to look for when we talk about future of mobility as well.
History doesn't necessarily repeat itself, but it always rhymes, to quote Mark Twain. Today is tomorrow, tomorrow is today, the future is Magna. Joerg, thank you so much for coming on SAE Tomorrow Today.
Thank you very much. It was my pleasure.
Thank you for listening to SAE Tomorrow Today. If you've enjoyed this episode, please kindly rate and review on your favorite podcast platform. Your feedback is invaluable to us as we work to produce world-class content.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.